in this video, I'm going to work through the double displacement homework. Hopefully this will be helpful. Okay, solutions of zinc bromide and silver nitrate are combined. Zinc has a charge of +2 and bromide is -1, so I need a 2 there. Silver nitrate, silver is +1 and nitrate is NO3 -1. No subscripts are needed. The silver and the zinc are going to switch places. So the silver and the bromine go together. Silver is +1, bromine's -1, no subscripts needed. Zinc is +2 and nitrate is -1. So we'll need 2 of those. Now, when I look on the solubility table, I'm going to look up silver bromide, and I see an I there. An I means it's nearly insoluble, it's a solid. So this gets an S. The zinc nitrate is aqueous. I think it's worth noting here that down at the bottom of the page, you'll notice that all nitrates are soluble. So I'm going to balance the equation. I've got 2 bromines on the reactant side, so I need 2 on the product side, and balance out the silvers, and that should do it. Okay, barium chloride, Ba is +2 and chlorine is -1, so I need 2 of those. And potassium carbonate are mixed together. Potassium is +1, carbonate is CO3 -2, so I need a 2 there. The potassium and barium switch places, so the potassium and the chlorine go together. Potassium is +1, chlorine is -1, no subscripts needed. And the barium and the carbonate go together. Barium is +2, carbonate is CO3 -2, no extra subscripts needed. Carbonates are insoluble. You can look on the solubility chart for that. That's a solid, and this is aqueous. So we'll balance the equation. I'll need 2 potassiums on the product side, and that should do it. Next one, a solution of aluminum nitrate. Aluminum is +3, nitrate is -1, so we need 3 of those. Is added to a solution of sodium hydroxide. Sodium is +1, hydroxide is -1. No subscript needed. The sodium and the aluminum switch places, so the sodium and the NO3 go together. Sodium is +1, NO3 is -1, so I don't need any extra subscripts. And the aluminum and the hydroxide go together. Aluminum is +3, hydroxide is -1, so I need 3 of those. Hydroxides are pretty insoluble, that's going to be our solid, and NO3 is going to be aqueous. Again, I'm not going to pull out this chart every single time, but if you're having trouble using this, please let me know. As an example, here's that aluminum hydroxide. You can see the little I there. If I see an I or an SS, meaning slightly soluble, or I for insoluble, that means I have a solid precipitate, and I should always write an S next to the precipitate. Don't write an I there or an SS, it's only an S. And it doesn't matter which order you put these products. Anyway, to balance this equation, I need 3 hydroxides on my reactant side and 3 sodiums, so that should balance out. A solution of calcium chloride. Calcium is +2, chlorine is -1, so I need 2 of those. Is added to a solution of sodium carbonate. Sodium is +1, carbonate is -2, so I need 2 of those. So the sodium and the calcium switch. The sodium and the chlorine go together. Sodium is +1, chlorine is -1, no subscripts needed. And the calcium and the carbonate go together. Calcium is +2 and carbonate is -2. No extra subscripts needed. Here's our solid. Salt is aqueous. And so we can balance the equation by adding a 2 here. So there's 2 sodiums on both sides and 2 chlorines. A solution of nickel 2 bromide. Nickel has a charge of +2 because of that 2, and bromine has a charge of -1, so I need a 2 there. Is added to a solution of potassium hydroxide. Potassium is +1, hydroxide is -1, no subscripts needed. Potassium and nickel switch, so the potassium and bromine go together. Potassium is +1, bromine is -1, no subscripts. And the nickel and hydroxide go together. Nickel is +2 because of the Roman numeral. Hydroxide is -1, so I need 2 of those. And the hydroxide will be a solid. And here's our aqueous. And to balance it, we need 2 hydroxides on the reactant side, 2 potassiums on the product side. Okay, sulfuric acid is an acid, and the formulas for the acids are on the back of the periodic table under common acids. Sulfuric acid is H2SO4. H2SO4 plus potassium hydroxide, which we've had before. The K and the H switch places. The K and the SO4 go together. Potassium is +1. Sulfate is -2, so I need a 2 there. Plus, the hydrogen and hydroxide go together. Well, that's just water. Hydrogen is +1, hydroxide is -1. So you can either write it like this or just write H2O. That's a liquid. It'll stick together, so this is a reaction that will take place even though this is just an aqueous product here. Because I make water here, this is going to work. So I can balance this in equation with a 2 here and a 2 here. So I get 2 hydroxides on both sides. Okay, next one, a piece of calcium hydride. Calcium is +2, hydride is H-1, is added to water. Now I'm going to write water as HOH. So I'm going to switch the hydrogen and the calcium. So the calcium is going to get together with hydroxide. Calcium is +2, hydroxide is -1. So I need 2 of those. And the hydrogen is just going to go together with hydrogen to make hydrogen gas, which is diatomic. Now that's a molecule that would stick together. So that's a gas, and this will work. This is a solid, insoluble product. And to balance it, I'm going to need 2 hydroxides, so I'll put a 2 here, and that'll give us 4 hydrogens, so I need a 2 there. Okay, a solution of barium bromide. Barium is +2, bromide is -1, so I need a 2 there. Is added to potassium hydroxide again. Pat's seen that before. The potassium and the barium switch places. So the potassium and the bromine go together. K is +1, bromine is -1, so I don't need any subscripts. And the barium and hydroxide go together. Barium is +2, hydroxide is -1, so I need 2 of them. Hydroxides are inevitably insoluble, and the potassium bromide is aqueous. So to balance it, I need 2 hydroxides on the reactant side and 2 potassiums on the product side. Almost done. A solution of ammonium hydroxide. Ammonium is NH4, hydroxide is OH, this is +1 and -1. Is added to iron 3 chloride. Iron has a charge of +3 because of that Roman numeral, and chloride has a charge of -3, so I need a 3 there. I said that wrong. Chlorine has a charge of -1, so I need 3 of them. The iron and the ammonium switch. So the iron and hydroxide go together. Iron is +3, hydroxide is -1, so we'll need 3 of those. And the ammonium is +1, gets together with chloride, -1. So I don't need any extra subscripts. The hydroxide's a solid, so we get a precipitate, and we need to balance the hydroxides. So we need 3 hydroxides on the reactant side, and then 3 ammoniums on the product side. Last one, hydrochloric acid. That's a acid from our acid table right here, HCl. Hydrochloric acid is added to a solution of aluminum oxide. Aluminum is +3, oxide is -2, so we need a 2 there and a 3 there. The aluminum and hydrogen switch, so the aluminum and the chloride go together. Aluminum is +3, chlorine is -1, so we need a 3 there. And hydrogen gets together with oxygen to make water. Hydrogen is +1, oxygen -2, so we get H2O. This is a liquid. It's a molecule that sticks together, so this reaction will work. To balance it, actually this is aqueous, we need 3 chlorides on a reactant side, and we need 2 aluminum, so I'll go like that. Actually, we're going to make this 6 chlorides, 6 hydrogens, 6 hydrogens, 3 oxygens, there we go. That should do it. Don't hesitate to let me know if you have any questions. Hope that was helpful.